In lesson 28, it talks about rational expressions, simplifying rational expressions, and also just talking about what they are, what excluded values are. Let me address these things first of all. First, I want to say this. Your attitude toward any class will affect how well you do in that class. And this is not just about getting 100%, but even appreciating what you've learned in that class. If you don't understand something, look for your teacher, tell them what's going through your mind, and try and see how they can help you through that problem. But never allow a bad attitude to take a hold of your life. Make sure that you have an attitude that is like that of Christ. The Bible says in Philippians that we should have an attitude that is similar to what the attitude of Christ was. We have to be humble in our dealings, not just in in our faith, but it should reflect in how we treat others in class and how we treat those we meet along the way. So make sure that your attitude is like that of Christ. And as we read the Gospels, as we read the Bible, we can learn more about the attitude that Christ had. And we should be like-minded, or we should have the mind of Christ, even as we're reminded in Romans chapter 12. So make sure that your attitude is one that brings honor to God. Number 2, let's talk about excluded values for a second. Whenever you're dealing with a rational expression and the denominator is such that it can be 0, you know that whatever makes that denominator 0 is an excluded value. So for example, if you had this, 2x squared minus x plus 8. 2x squared minus x plus 8 over x plus 3. The excluded value is -3, because if you put -3, it will make the denominator 0. So how do we find excluded values? All we do is we set the denominator equal to 0, and then the answer we get is the excluded value, because that's what makes the denominator 0. That value is the excluded value. So make sure you understand that. Rational expressions are simply occur when you have one polynomial divided by another one. They're basic. This is a rational expression, and there's more that we're going to work with. And I'm going to teach you how to simplify rational expressions. That's what this video is about. So let's go ahead and do some examples with rational expressions. Before we do that, let me mention that you can have one excluded value, or you can even have situations where you have no excluded value, like x squared over 4. There's no excluded value. Or you can have 2 excluded values. Let's talk about a problem with 2 excluded values. 5 divided by x squared plus 3x plus 2. When you're given this expression, you need to realize there's a quadratic expression in this rational expression. And so you should solve the quadratic expression. Always solve quadratic expressions when you see them in rational expressions. Always solve them, because that will help in simplifying the whole problem. So when you take this problem and you use the AC method or whatever method you choose, you can solve and get the 2 brackets, x plus 2, x plus 1. And you know that the excluded value would be either -2 or -1. So those are the 2 possible excluded values. Those numbers will make the whole thing 0, and that will be a problem, right? So that's how you do this problem. Now let's move on and do 5 problems that have to do with simplifying rational expressions. And this should help you with lesson 25. This is also helpful to geometry students, anybody who wants to do better in doing math problems. So the first one, 4y to the 5th divided by 8y squared. That's the question. Again, these are the questions that I'm giving you, A, B, C, D, and E. And we're going to look at them one by one. These are additional examples to help you understand the chapter. And so when you have A the way it is, what you need to do is, first of all, remember that I call my dealing with exponents laws of indices, but the book used a different term, but it's still the same concept. When you have the same base, you're allowed to subtract the exponent of this one from that. So it becomes -2. So you're bringing this up. So then we get rid of this y right here. You look at the 4 and the 8. 4 goes into 4 once. It goes into 8 twice. All you have left is y to the 3rd power divided by 2. That's all you do for the first problem. You've simplified that rational expression. And again, just take it step by step. Deal with the y and then deal with the whole number. B, when you have z divided by z to the 5th power, all you do is you simplify using, again, one of the laws of indices, which says that we can bring this exponent to this. So it's basically z to the first power minus 5, which is equal to z to the negative fourth power, which is equal to 1 over z to the fourth. That's another way of writing it. And that's how you simplify that problem. Again, this should be helpful to geometry students. The third one, we have c. We basically take this, it's 2 into x squared minus 4 divided by x plus 2. First of all, we're going to talk about what the exclusion value is. The exclusion value is minus 2 because it makes the denominator 0. So it cannot be included in the solution or in the range. That makes the range undefined. So what you do here is, first of all, look at the difference of two squares. X squared minus 4. So that's 2 into x squared minus 2 squared divided by x plus 2. Right? And so that can be rewritten based on what you know about the difference of two squares as 2 into x plus 2 x minus 2 divided by x plus 2. Again, the difference of two squares simply allows us to write out the first power of the first term, the first power of the second term, and then and so on and so forth. Let me just give you an example of a complex problem of a difference of two squares. If I ask you to do 4x squared y squared minus 81, I hope you see that all you need to do is write it out as 2 squared x squared y squared minus 9 squared, which is 2xy minus 9, and then times 2xy plus 9. That's all you do with that problem. This is just an example of working with difference of two squares on a more complex level. But let's finish our problem here. 2 into x plus 2x minus 2 divided by x plus 2. The x plus 2's cancel out. So you have 2 into x minus 2 as the answer. If you want to break it down further, you can distribute and you get 2x minus 4. That's how you do number C. D is a little interesting. I'm going to move over here and do the D, and then I'm going to finish over here with E. So for D, you have 10 into 4 minus 3x divided by 15 into 3x minus 4. As is written right now, you can't do much, but you need to realize that you can rewrite. Well, first of all, you can simplify, the 10. 5 goes into 10 2 times. 5 goes into 15 3 times. So right now we have 2 over 3, and then we have 4 minus 3x, and then into 3x minus 4. So that's the form we have it in right now. The next thing you need to do is rearrange it so that you have this equal to that. How do you do that? Well, the first thing is, let's write the x's. Let's align the x's. We would get 2 into negative 3x plus 4 divided by 3 into 3x minus 4. And what happens is you have 2 into minus 3x plus 4 and then 3x minus 4. You can take out the minus 1 and bring it out to the front. Let's continue D on this side. So we take out the minus 1, so we get minus 2 into 3x minus 4 divided by 3 into 3x minus 4. At this point, you can cancel out the 3x minus 4, and all you have is minus 2 over 3 as your final answer. That's how you deal with that problem. If they asked you to find the exclusion value for this, all you would do would be to simply set the denominator equal to 0. So 3x minus 4 is equal to 0, or 3 into 3x minus 4 equal to 0, and then you solve for x. That would be the exclusion value. I'm going to make a second video to solve the last problem because it's a longer problem, and hopefully that will be helpful in your homework. So we're going to stop here for now.